Moving on to Chapter 2, Section 2.1, Frequency Distributions. A frequency distribution is just a table of values that occur in a data set and how often each value or range of values occurs. There are two basic types of frequency distributions: group distributions and ungrouped distributions. An example of an ungrouped frequency distribution is the following. We have grades that students can receive in a class and the number of students that have received each grade. Notice that this tells us 5 students have received an A, 14 have received a B, 9 have received a C, 3 have received a D, and 1 student has received an F. In this case, it seems natural for each data value consisting of letter grades, A, B, C, D, or F, to have its own category, or what we call class. Since there are only 5 classes, an ungrouped frequency table is reasonable. Let's ask ourselves a question. What if instead we formed an ungrouped frequency distribution for the number of grades of a test with a 100-point scale and not the letter grades? We would then have 100 different classes, one for each test score, right? We would have a class for receiving 100, a class for receiving a 99, one for 98, one for 97, and so forth. Not only would this be unreasonable, it would probably not depict a clear pattern to the data. Instead, we would most likely group the data into a table that looks similar to our previous table. Now, we can organize our A's, B's, C's, D's, and F's. This is an example of what we call a grouped frequency distribution. Notice that each class is a range of values, and each value shows up in only one class. The technique for creating a group frequency distribution is as follows. First, we decide how many classes should be in the distribution. Several different methods can be used to determine the number of classes that will show the data most clearly. But in this textbook, the number of classes for a given data set will be suggested. Step 2, choose an appropriate class width. The class width is the number of values in the range of values in a given class. For example, if we look at our class width here for this group frequency distribution, our class width would be the number of values in each class here. Again, several different methods can be used to determine the class width, but in this textbook, the class width for a given data set will be suggested, and each class will have the same class width. Step 3, find the class limits. The lower class limit is the smallest number that can belong to a particular class, and the upper class limit is the largest number that can belong to a class. Each problem will give the lower class limit for the first class. To find the remaining lower class limits, continue to add the class width to this value. The upper class limits are chosen such that the classes do not overlap. Step 4, determine the frequency of each class. Make a tally mark for each data value in the appropriate class. Count the marks to find the total frequency for each class. Let's look at an example. Consider the following group frequency distribution. Notice that there are 5 classes. The first class consists of the values 15 through 19, and they include the endpoints. So here's our lower class limit, and our upper class limit. The second class includes the numbers 20 to 24. The third class includes the numbers 25 to 29. The fourth class, 30 to 34. And finally, the fifth class, 35 to 39. Notice also that the first class contains the values 15 through 19. So if we count 15, 16, 17, 18, and 19, there are 5 values. The second class also contains 5 values, 20, 21, 22, 23, and 24. The third class, the fourth class, and the fifth class also contain 5 values, and we can easily count those. So the class width in this case is 5, since each class contains 5 values. The frequencies given in the table are 7, 8, 10, 2, and 3. Let's go back. So there's 7 data values that are between 15 and 19, 8 data values that are 20 to 24, 10 that are 25 to 29, 2 that are 30 to 34, and 3 that are 35 to 39. Now this does not tell us what the exact values are, of course. However, it does allow us to see a trend or pattern in the data. Let's look at an example. The following data represents the weights in pounds of 24 collegiate offensive linemen in a particular state. Use 6 classes that have a class width of 25 pounds. And begin with a lower class limit of 175. And what we want to do is create a frequency distribution with the indicated number of classes for the given set of data. Okay, let's solve this problem. So here is our given data, and we need to create our 6 classes. That's what the problem told us. And our frequency for each class. Now I'm going to write my classes as my lower limit all the way to my upper limit. And they tell us to start at the value 175. Now from the problem, we know that the class width is 25 pounds, because these data represent pounds. I'm going to use that to obtain all of my remaining lower limits. To do so, I add 25 to each previous lower limit. So to get my lower limit for the second class, I add 25. So I get 200. To get my next lower limit, I add 25. To get 225, my next one will be 250. Then 275, and then 300. Again, I'm just adding 25 at each step. Now to obtain my upper limits, I have to think at first. The upper limit of the first class is going to end right before the lower limit of the following class. So what number comes right before 200? That's right, 199. Now I can keep playing this game. What number comes before 225? And we all say 224. I can keep doing it this method, or I can use my trick and continue to add my class width. 199 plus 25 is 224. 224 plus 25 is 249. 249 plus 25 is 274. And then we get 299. and then we get 324. So to go from my lower limit to my next lower limit, I can add my class width. Similarly, to go from my upper limit to my next upper limit, I can add my class width. I can't interchange these. I have to stay in my lower limit column or stay in my upper limit column. I can't move around with 25. I have to stay in my columns. Now we need to create our frequencies for each class. So I'm going to look at every data value that's 175 all the way to 199. And I'm going to cross it out. Notice that 195 is in this range. 178 is also in this range. 196 and 189, and finally 199, because we can include the endpoints. So now we count 1, 2, 3, 4, and 5. So the frequency for our first class is 5. Continuing on, tallying each data value, we get the following frequency table. So here are our 6 classes, and here are the corresponding frequencies for each of those classes. There are other characteristics of a frequency distribution that can be calculated once the basic frequency table has been constructed. We will look at 4 of them. The first, the class boundaries split the difference in the gap between the upper limit of one class and the lower limit of the next class. To find each lower class boundary, we simply subtract 0.5 from each lower limit. To find each upper class boundary, we simply add 0.5 to each upper class limit. The class midpoint is the value in the middle of the class. It is the sum of the lower and upper limits of the class divided by 2. So we take the lower limit and add the upper limit, then we divide by 2. And this gives us the midpoint, or middle of the class. The relative frequency is the fraction or percentage of the data set that falls into a particular class. It is calculated by dividing the class frequency by the sample size we denote by n. The relative frequency is a fraction. It's the frequency of the class divided by the total number of data values. Finally, the cumulative frequency is the sum of the frequencies of a given class and all previous classes. A good practice exercise is to try finding the 4 items: the class boundaries, the midpoints, the relative frequencies, and the cumulative frequencies with this frequency table that we just did. If you have any questions, please email me.